আচ্ছা, লাস্ট ক্লাসে আমরা ফিজিক্সের জন্য দরকার কিছু গ্রাফ, কিছু রিলেটেড গ্রাফ, কিছু কনিক সেকশন নিয়ে আলোচনা স্টার্ট করেছিলাম। আমি ইলিপস আলোচনা করছিলাম। ওকে, ইন দ্য লাস্ট ক্লাস উই ডিসকাসড অ্যাবাউট প্রিলিমিনারি কনসেপ্ট অ্যাবাউট ইলিপস, whose concept is very much necessary for understanding of physics, basically in the branch of gravitation, where we shall deal with the different paths followed by the different types of satellites or planets or different types of planetary bodies, etc. So let us draw a simple example. Let us draw our attention to in solving a simple example like that. Let the equation of a curve is given by like this. It is 9x square minus 36x plus 4y square minus 24y plus 36 equal to 0. Okay, in the last class I started discussing on this type of curve represented by this type of equation. Let us repeat again about the ideas how to sketch this type of variations. Clearly it is very clear from this equation that it cannot be a circle, because we know the familiar equation of a circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. So that is the coefficient of x and y, x square and y square, in the familiar equation of a circle should be 1. If I take a 9 as common term, then the coefficient of y square becomes 4 by 9. So it cannot be a circle, first of all. Now let us write the equation in the form, or 9x square minus 36x plus 36 plus 4y square minus 24y plus 36 minus 36 equal to 0. I can write the equation in the form, that is, or 9 into x square minus 4x plus 4 plus 4 into y square minus 6y plus 9 equal to 36. It is a repetition of our last class, or 9 into x minus 2 whole square plus 4 into y minus 3 whole square equal to 36. Okay, so dividing both sides by 36, we have x minus 2 whole square by 4 plus y minus 3 whole square by 9 equals to 1. X minus 2 whole square by 4 plus y minus 3 whole square by 9 equals to 1. Okay, so it is a familiar equation of an ellipse with its center of the ellipse is at 2, 3, and the axis of the ellipse is calculated by taking x minus 2 equal to 0, and the axes are chosen by setting x minus 2 equal to 0 and y minus 3 equal to 0. So the axis of the ellipse x minus 2 equal to 0, that is x equal to 2, and another axis, it is y minus 3 equal to 0 or y equal to 3. Now to plot the graph, we have to find some important points, that is, if there are some points of intersection of this curve with the positive x or positive y axis, or respectively the xy axis. First let us find out those points of intersection, if any. Okay, I am erasing the first two steps. Look, if you put x equal to 0, if you put x equal to 0 here, that is, I get minus 2 whole square by 4 plus y minus 3 whole square by 9 equals to 1, or that is 4 by 4, it is 1, that means y minus 3 whole square equal to 9, or y minus 3 equals to plus minus 3. Okay, now erasing the another term, or y equals to 3 plus minus 3. So value of y may be 0 and 6. So the point of, so for x equal to 0, we have two values of y, that is y equal to 0 and y equal to 6. So the point of intersection, for x equal to 0, y equal to 0 and y equal to 6. So the graph will have the graph will have a point of intersection on the y-axis. Graph will have a point of intersection on the y-axis. Okay. Similarly, to find out the point of intersection with x-axis, if we put y equal to 0, our equation was x minus 2 whole square by 4 plus y minus 3 whole square by 9, that is 1. If you put y equal to 0, that means x minus 2 whole square equals to 4, or x minus 2 equal to plus minus 2, or x equal to 2 plus minus 2, that is x equal to 0 and 4. X equal to 0 and 4. Okay. So now let us now sketch the curve as desired. And I have previously found the coordinate of that point, that is the point of intersection of the particular ellipse. Point of intersection of the particular ellipse with its one of its axis, that is say y equals to 3. One of its axis y equal to 3. I know that there are two major axes of the ellipse. One is x minus 2 equal to 0 or x equal to 2, and y minus 3 equal to 0 or y equal to 3. So let us sketch the graph. And you all know that the length of the semi-major axis is less than the length of the semi-minor axis. It is x, it is y. Now, for x equal to 0 and y equal to 0, or if we put x equal to 0 and y equal to 0, then definitely the equation is not satisfied. So the graph does not pass through the origin. Okay, does not pass through the origin. It passes through the point 0, 6, x equal to 0, y equal to 6. It passes through the point, and it also passes through the point, 0, 4, y equal to 0 and y equal to 4. It may be. Maybe of the form like that. There are two axes of the graph. It is y equal to 3, and this curve is x equal to 2. This is the center of the ellipse, that is 2, 3. Okay, the graph should be like that. Okay, now let us draw our attention about an elementary discussion about hyperbola. Oh. Okay, the familiar equation of a hyperbola may be written as, x square by a square hyperbola. X square by a square minus y square by b square equals to 1. The familiar equation of a hyperbola may be written as x square by a square minus y square by b square equal to 1. X square by a square minus y square by b square equal to 1. Okay, now you just check the hyperbola neither passes through the point 0, 0. That is, if you put x equal to 0 and y equal to 0, that is the hyperbola equation is not satisfied. That is, it does not pass through the origin. Now, if you put x equal to a, if we put x equal to a, that is x square equal to a square, or x equal to plus minus a, then y square by b square equal to 0, or y equal to simply 0. Y equal to simply 0. That is the vertex of the parabola, vertices of the hyperbola, lies at a comma 0 and minus a comma 0. And x equal to 0 and y equal to 0, x equal to 0 and y equal to 0 are two asymptotes to this hyperbola. X equal to 0 and y equal to 0 are two asymptotes to this hyperbola. So, how the graph will look like? X equal to 0, that is y axis, and y equal to 0, that is x axis, are two asymptotes to the hyperbola. Two asymptotes to this hyperbola. Okay. Now, how the graph will look like? It is our x-axis, it is our y-axis. So, this is x-axis, it is for y equal to 0. This is the line x equal to 0. It is our origin. So, this point should be a comma 0, this point should be minus a comma 0. They are the corresponding asymptotes. Okay, they are the corresponding asymptotes. It is one asymptote. So, the axis, okay, the axis of the hyperbola are x-axis and y-axis, and the corresponding asymptotes are these dotted lines shown in the figure. Okay. Now let the equation of the hyperbola is written in the form y square by b square minus x square by a square equals to 1. And let the equation of the hyperbola is written in the form y square by b square minus x square by a square equal to 1. It is also an equation of the hyperbola, and like our previous discussion or from our previous conception, that it also does not pass to the origin, that is x equal to 0 and y equal to 0. Putting this value, this equation is not satisfied. Now if you put y square equal to b square, or y equal to plus minus b, then x equal to 0. So the vertices of this hyperbola, the axis of the hyperbola will be x equal to 0 and y equal to 0. That is x-axis and y-axis. That is the axis of the hyperbola will be x equal to 0, that is y-axis, and y equal to 0, that is x-axis. Okay, the axis of the hyperbola. But the vertices will be 0, comma b and 0, comma minus b. Now let us sketch the hyperbola and let us see how the graph looks like. This is our x-axis, this is our y-axis. 0, comma b and 0, comma minus b. It is 0, comma 0, it is 0, comma b, it is 0, comma minus b. Okay. And if you want to draw the asymptote, it will be like that. And another asymptote I am trying to draw, okay, it is not as per scale, will be like that. These two dotted lines represents the two asymptotes to this hyperbola. Okay. Now let us draw simple graph. For example, let us draw a graph of the given equation. Let x minus 1 square by 9 minus y minus 2 square by 4 equals to 1. Let the equation of a curve is given by x minus 1 square by 9 minus y minus 2 square by 4 equals to 1. Okay. So the axis of this hyperbola, will be x minus 1 equal to 0 or x equal to 1, that is a line parallel to y axis, and another axis will be y minus 2 equal to 0 or y equal to 2, that is a straight line parallel to x axis. These two are the axes of the hyperbola. And to find out the coordinates of the center of the hyperbola, we put x minus 1 equal to 0 or x equal to 1 and y minus 2 equal to 0 or y equals to 2. So the center of the hyperbola is 1, 2. Center of the hyperbola will be 1, 2. Now I have to find out its vertices. Okay. Look, if I put x equal to 1 to find out the vertices, if you put x minus 1 equal to 0, okay, now you try to find out the vertices. Look, if I put x minus 1 square equal to 9, then x minus 1 equal to plus minus 3, or x equal to 1 plus minus 3, that is x equal to 4, minus 2. For these values of x equal to either 4, or minus 2, you will get y equal to 0. And what you will get? Y equals to, for x equals to 4 and minus 2, when x equal to 4, this term becomes 1. When x equal to minus 2 also, this term again becomes 1. So you will get y minus 2 whole square by 4 equal to 0, or y minus 2 square equal to 0, or y equals to 2. So the vertices of the hyperbola is given by 4, 2 and minus 2, 2. So the vertices of the hyperbola is given by 4, 2 and minus 2, 2. Now you first try to draw the hyperbola. Okay. Okay. Let this our reference. This is our reference axis, x and y. It is 0, 0. And the axis of the hyperbola is given as we have already found. It is x equal to 1 and y equal to 2. Say this is x equal to 1. Say this is y equal to 2. So coordinate of this point, it is 0, 2. This point it is 1, 0. It is x equal to 1 and this line is y equal to 2. This is toward the axis. And the center of the hyperbola, you have already found that it will be the center. It is 1, 2. Now, the vertices is 4, 2 and minus 2, 2. So, minus 2, 2, it will be located in this quadrant, that is in the second quadrant, minus 2, 2. So, it should be like that. And another, it is 4, 2. So, it should be like here. Okay. So the sketch of the hyperbola will be just like this. Okay. Now let us discuss in very short about the concept of rectangular hyperbola, which is very much important in physics, because as you have already known that while dealing with the gas laws, specifically in case of the Boyle's law, when the mass and temperature of a gas remains constant, you have already known that PV equal to constant. That is, the graph of P versus V or V versus P is a rectangular hyperbola. You have already taught it in your previous class. So the concept of rectangular hyperbola is very much important in the different portions of physics in dealing with such graphs. Okay. Now, the familiar equation of a hyperbola is, you have already learned that x square by a square minus y square by b square equal to 1. It is the familiar equation of a hyperbola. X square by a square minus y square by b square equal to 1. Okay. Now, if a equal to b, then we find x square minus y square, that is equals to a square. Okay. So it is known as the equation of a rectangular hyperbola, because from this equation we shall get xy equal to constant. From this equation we shall get xy equal to constant. So the familiar equation of a rectangular hyperbola, can be written as, x minus alpha into y minus beta equal to some constant c. This is the familiar equation of a rectangular hyperbola. X minus alpha into y minus beta equal to c. This constant c, it may be positive or it may be a negative number also. Okay. So if x minus alpha into y minus beta equal to c, then the asymptotes to the curve will be, asymptotes to this hyperbola will be x minus alpha equal to 0, that is x equal to alpha. It will be an asymptote to the hyperbola, and similarly y minus beta equal to 0 or y equal to beta. So the two asymptotes to this rectangular hyperbola, are given by the straight lines x equal to alpha, which is parallel to y axis, and y equal to beta, which is parallel to x axis. These two are the asymptotes. Okay. But if xy equal to c, let xy equal to c, let c is positive, a positive number. First let us draw this type of curve. Let c is a positive number. So the asymptotes to this curve will be x equal to 0 and y equal to 0. So the asymptotes equations, asymptotes will be x equal to 0, that is y axis, and y equal to 0, that is x axis. Now let us draw such curve. It is our x axis, it is our y axis. Okay, this type of curve will be. And the center of the hyperbola will be at the origin, that is 0, 0. Okay. Now let we deal with especially two types of rectangular hyperbolas. We are dealing with two types of rectangular hyperbolas. One is given xy equal to c1, another is given xy equal to c2. Let both are positive constants, c1 and c2 both are positive, and c2 greater than c1. Let c1 and c2 both are positive and c2 greater than c1. Then how it will look like? From our previous discussion, it is also clear that the center will be at 0, 0, and the corresponding asymptotes will be x axis and y axis respectively. These are the two asymptotes. For this, it is xy equal to C1 and another curve is xy equals to C2. These two are the corresponding asymptotes. Okay. Now, there is another important question. Let xy equal to constant c where c is a negative number. Let xy is a constant c where c is a negative number. Then how the hyperbola, rectangular hyperbola will look? Okay. So this is for xy equal to c where c is negative. Okay. Now for a simple example, let I have been asked to draw the graph of y equals to 1 by x minus 1. Y equals to 1 by x minus 1. From the very nature of the equation given in the board, you are convinced that it should be a rectangular hyperbola. Now how to sketch that? That is y equals to y into x minus 1 equals to 1. So I can compare this equation with our familiar equation of rectangular hyperbola, which was y minus alpha say into x minus beta equal to some constant. With comparison of these two equations, I am getting alpha equal to 0 and beta equals to 1. So the center of this rectangular hyperbola, center of the rectangular hyperbola, hyperbola, it will be 1 comma 0. Center of this rectangular hyperbola will be 1 comma 0. Okay. Now the asymptotes to this hyperbola, it will be y equal to 0, that is x axis, it is an asymptote, and another asymptote will be x minus 1 equal to 0 or x equal to 1. This is a straight line parallel to y axis. These two are the corresponding asymptotes. Now let us draw this type of graphs. It is our 0 comma 0. Now let us draw the straight lines x equal to 1. So this is a straight line, it is say 1. So this line is x equals to 1, and another it is y equal to 0. This is the x axis. So how the corresponding asymptote will look? The asymptotes are x equal to 1 and another asymptote is y equal to 0. Y equal to 0, that is x axis. Y equal to 0, that is x axis. So it is x equal to 1, this asymptote, another asymptote is y equal to 0, that is x axis. So you think how it will look like? And obviously another important thing, that is c, for c equal to 1, that is positive. The form should be like that. Okay. So this is the sketch of the rectangular hyperbola for this equation. If c comes out to be negative, then that should be like that, in this way, in that way. Okay. Okay. Today up to this, I am returning back with another concept of some another graphs.